Huh? Alright, so today we are going to get started on cutting metal. The first part of this model that we're going to work on is the deck with all the various simulated tanks on it. As I mentioned before, the R and N models of the D11 are different when it comes to this area, and I did some further research and was able to isolate even more differences, and so we're going to go ahead and get started on that. All the red lines on here indicate spots that I'm going to cut and parts that I'm going to get rid of. So the first thing I'm going to do is, and I'm going to do all my work with a handsaw. I did order a flex shaft handpiece, it just hasn't shown up yet. But I'm going to do it with the handsaw, and also I want to show you guys how to do stuff like this with hand tools, and then later on we'll get into the power tools, because hand tools allow you to be a little bit more precise, especially when you're newer at using stuff like this, and it's easier to keep from messing up big time when you use a hand tool opposed to something that cuts a lot faster. So to recap the major differences between the N and the R, the early N models, I'm guessing this whole section right here is the fuel tank. The more that I look at the photos, it's completely flush across the back of it, meaning it's got one entire piece instead of this dip in the middle, the little view spot. And it's actually, looking at the photos, 3 panels. So it's like 1 panel, 2 panel, and then a panel that covers it. So what I'm going to do is this rear section right here, I'm going to take and grind down. You can see I have these red marks right there on the top. It's going to get ground down so that this angle on the side is more like that. And then I'll come back in and affix some brass panels to here, and then make the panel that goes over the middle. As far as the hydraulic tank goes on the N model, it's not as pretty as the one that's on the R. The R, they made it nice and streamlined. It matches the whole rest of the profile. On the N model, it's actually, it kind of looks like an afterthought. It sits in a few inches back. It's a little bit shorter this way, and then it has 2 retainers on it where it's been bolted down to the deck. The filler cap is also different on it. This one has, I think that's the filler cap, unless maybe that's the pump motor. It's a little bit different. It's set farther down in. Actually, I think that is the pump motor. So this is going to get, all this is going to be gone. I'm going to cut all of this off, and then I'm going to remake that out of brass as well. The other side is pretty basic. On the N models, I've noticed some do have this right here. This is basically a little, I think it's either a toolbox, a utility cabinet, or maybe that's where the cutoff switches for the battery, which I don't think so. I think the battery cutoff switch is somewhere down here. So I believe it's probably just a toolbox. And the real size D11s that I've seen that have this also all seem to have the engine cover pack as well. So maybe it was an option from Caterpillar that you would get. And I don't think there's much else to change on here. So let's get started with cutting some metal apart. Alright, for the cutting, the tool that I'm using is just a handsaw, simply called a razor saw. The blade that's on it is a 32 TPI, which basically means 32 teeth per inch. And I have a couple other blades here that we might be using as well. These came with it. It comes in a kit of 4 blades. These are both 24 TPI, tooth per inch. It's also the same size blade that I have on my bandsaw. It's a 24 TPI. And then I've mounted it up here in this vise. It's a cheap, inexpensive Harbor Freight vise. It swivels and rotates 3 different ways, which is really useful. And just got it locked in here on the top. So let's start cutting. I have it held by the thing that screws this together to the rest of the model, so I'm trying not to put too much pressure on it, because I don't want to crush the little metal tube. Oh, and if you're wondering why I'm cutting across this whole thing, it's because I want to add realism to it by separating the various tanks and components that are on it. So that's why I'm cutting the other side as well. Even though I'm not making any modifications to this side, I want to have that wider panel gap look. And I'll back it with some plastic back behind there to add an end to the ledge, but just for added detail. And it also makes it easier to make this cut if I can go all the way across. Alright, we're almost all the way through. And through on this side as well. Just checking the depth of the blade against this, and it looks good. I'm not too concerned about the cut on the inside right here. Just more concerned about that on the outside. It looks good. Alright, so now that this cut is complete, we're going to make our next cut, which is going to go this way. It's basically going to be a diagonal cut from this point right here to this point right here, so that I can free up all this material around along there. And I'm actually going to cut down this way a bit as well. That's actually, I think, going to be my first cut, and then I'll come in and do the diagonal. Alright, so I've stopped halfway through this. The blade is starting to creep down this way. It's not staying flush against this, and it's because I'm going at this diagonal here, and the blade is pressing against this part right here. And so it's starting to take and turn the blade down. It's not something that I'm going to be able to change unless I take and like bend this down and then hope that I can make that correction. So what I'm going to do now is I'm going to go over to the disc and belt grinder that I have, and I'm going to take and then grind this top portion off, and eventually that's going to expose an opening, because again, we're getting rid of all this material right here anyways. It's going to expose an opening there, and then I'm going to come in with a smaller blade, cut this way, and then probably come in with the smaller blade and finish my cut that way. Because if I keep at this rate, if I keep at it, I risk cutting completely through the side piece, and I want to try to keep this intact as one piece. And you can see this red line here, that's where we're going to cut on the inside as well. So let's take it over to the grinder, sander, and check that out. Alright, so now it's time to use the belt sander here. Make sure you always wear respiratory protection every time you're going to use something like this on metal. We're just going to come in this way, and then we're taking this off all the way down to that line right there. Guantes. Alright, since my lovely little oversight there with the belt sander, I probably even looked at that once and went like, oh yeah, you probably shouldn't do it that way because you're gonna grind that down too, but apparently that didn't stick. So anyways, we're gonna change tactics here and get a little bit more aggressive. I'm gonna use a hacksaw. I'm gonna come down and cut diagonally across here, and basically remove this corner from where I started my cut already over here to this spot on the other side. Remove that corner, and then we'll work our way back to cut around. Again, the reason I'm going this length instead of just cutting this whole block out is because I want to keep this piece and this piece intact, because that's what supports the rollover protection, and that's what's going to help hold the cab down, because I'm going to actually fix the cab too. I know I mentioned earlier in one of the previous videos that the Northcott cab for this model is completely whacked, so I figured out how I'm going to fix it, but a lot of it's going to depend on the structural rigidity of this. So let's get to work. Okay, that's better. Just checking and making sure the blade is actually grabbing and creating a start. And then once it seats itself, then we can get more aggressive with it. Alright. I think, yeah, we've cut through. The only thing keeping it in place is that little bit right there. It's a lot of metal in there. Northcott used a lot of metal. Alright. So we have the front of that opened up now. Okay, so that was a lot of cutting, but I was able to get a pretty decent result. The only other problem was that it cracked right there. I think it was just because of all the pressure from the sawing, but that's fine. This will get all cleaned up later anyways. So when I come to put this back together and I make the hydraulic tank out of brass, I'm also going to create like an L-shaped floor of brass that's going to go under here. Let me cut this piece down so I can show you guys. I like to use cardstock. There's like templates, it works pretty good. So the piece will come under here and seal the floor, and then we'll be able to build it up a bit and install the new piece of brass that's going to go in right here. Alright, so I've started on the second one. This is going to be the one for my collection. A little bit screwed up, and I'm going to have to go back and make some fixes. And then this is going to be the one for the version that I'm going to sell. And I've actually done a little bit of a cleaner job coming in, so I want to show you guys at the halfway point what I've done differently on this one. Let's put this piece back on here. So the first cut I made was this cut along the base, and it's not completely cut through. It is, I think, cut all the way back to here. And then this face I cut back all the way to here, and then I'll continue to gradually make that smaller cut in, and then on the top I cut down this way, and then I cut in this way. So I cut this top piece off a little bit cleaner, and now that has opened this up for me. This is actually just a little bit of flash right there, and so now I'll be able to come in and then do another cut this way with that really small kind of pain in the neck blade to use, but it allowed me to get a really detailed cut in there. And then I'll be able to continue to kind of disassemble this and have a cleaner job. As you can see, a little bit of blade rub over here, but that was from the side of the blade, just rubbing the paint off the simulated non-slip that's on here. Second one came out much cleaner. Let's take a look here at both of them. More or less the same result, but this one I was able to keep this from cracking. And it was pretty easy. I'll come in later and clean up the edges with the file. Same thing with this one, clean all the edges up. And I guess it's time to move on to the next thing, which we're going to grind the back of this off. Alright, it's time to use the disc sander portion of my little sanding unit here. And remember to wear eye protection and respiratory protection anytime you're using something like this. I'm also using gloves. Now, some people say not to use gloves when you're around things like this because it can catch the glove. But this metal is going to get so hot that I'm not going to be able to touch it with my bare hands, so I'm wearing gloves. And I may actually have to take this away and cool it in water and then come back. Eventually we'll get a better unit. I want to get something with a cooling system on it and a bigger wheel, but again, this was a budget purchase and it's what works for right now. And I have it hooked up to a vacuum to suck a lot of the debris down and away. So let's get to work here. Alright, I think it's good. I think it's right to where I need it. And again, another reason why I leave the paint on there, it helps me line everything up. If this was all one color, it would be a lot harder, but because I have the paint, I'm able to use that as like visual lines. I think it looks good. I'm satisfied with it. Alright, so I'm going to kind of jump you guys in to midpoint here. So I just finished all the grinding and all the cutting, and I actually, since I've filmed last, have received my flex tool and got in here and cleaned up my cuts a lot more. And now I'm in the phase of planning the brass work that I'm going to do. I'm creating templates, and right now I'm just using some cardstock that came from literally some product that I got. It's just waste cardstock, but I like it because it's nice and heavy. You can also use styrene for this, but I think it's kind of a waste of the material. So what I'm doing right now is just basically figuring out how I'm going to make this out of brass. And this is a method that allows me to basically visualize what I'm putting together in my head. So this is just kind of like a rough template, and all I'm doing is just making my measurements and figuring out how I'm going to get all this done. So but this is basically simulating the base piece that's going to come in here. Earlier I had said that I was going to attach a piece to the bottom of this, but as I was just fitting this thing together and looking at how all the parts fit, which again is something that you really need to do when you're doing a custom build, because sometimes parts fit together in such a way that you don't think they do. And had I done the lower plate that I was originally intending on doing, it would have interfered with how this went together. So I had to come up with something different, and I think this second idea is actually going to be a lot better. Okay, so I have traced out my work onto the piece of brass here. You can kind of see it. I've done it in pencil, and then I've placed it in this miter box because I'm going to cut it by hand. And then I've locked it in place with this, and on the inside here I've put a little bit of cardstock as a wedge. See if you guys can see it's right. I've got this on the tripod, so it won't move back and forth. and we're going to hand cut it with the same tool that we've been using already. Eventually, amongst the millions of tools that I'd like to get, I plan on getting a micro table saw. They usually have blades that about this big around, and you can get ones with fine enough teeth to cut thin brass like this. Once I get that, that'll be really nice. I could cut this on the bandsaw, but I haven't built the bench for my bandsaw yet, and I'm just too lazy to pick it up off the ground, clear out room on my desk, put it up, set it up, just to make a couple small cuts. So we're going to do this by hand, and let's get started. Alright, yeah, that lasted about all of 30 seconds until I realized why I bought a bandsaw, because that takes too long. So I'm going to use my bandsaw. I'm going to rough cut this out, and then we'll use the bench sander and we'll fix things up. Remember, you're working close to a blade. Try to use a push tool when you can. I've had this thing grab like a little corner of this because it is thin metal, and just take and launch little pieces, and your finger goes in weird directions when that happens. So it's best if you're getting in front of the blade in anywhere in this area to have something that pushes. So all I'm going to do is just do some bulk cuts here, and then the rest of it's going to get done on the sander. Alright, let's take it over to the bench sander and finish it off. Oh, sanding. We have a satisfactory shape. This part right here will get bent down. This part right here will get bent up. It'll make sense later. The other half of what I cut this off of, and I will trace it on, and then do the same process over again. Bandsaw, sanding table. I'll see you guys in a few. Did I say sanding table? Tell me I didn't say that. I mean bench sander. Oh, Sandy. Right, now the base plates are finished. So we have all the bends in here that we need. And they fit pretty well somewhere along the line. I think I missed some measurement details here. Let's get in close enough for you guys to see. See, there's a little bit of a gap right here. That's not a big deal. It will be covered because I'm going to create a piece that's going to seal this up, and I'll just put it on the fascia right here to help seal that up. And also because I'm going to use putty when I put these down to kind of bond all this together, it should help seal it as well. So this is all, for the most part, done to satisfaction. So the next thing I've done is measured out the outside of the phantom piece right here. Let me show you my handy dandy drawing here. So I just did a quick sketch up of how that new hydraulic tank is going to look, and I did all my measurements. Basically, all I did was take this and measure off of it, and then created a little template to get my angle, and measured from there. So basically we have a piece that's going to be 18 millimeters wide, and I'm going to do one solid piece of brass that's going to have these 3 bends in it and create like a U-shaped shell that will ultimately get soldered to the base. Let's see here. So we have 7 millimeters plus 9 millimeters plus 8 millimeters plus 13 millimeters, 37 millimeters. So I'm going to cut, actually I've already cut one, I'll cut another one, but this is a strip of brass that will need to be shortened. I think this is about, let's see here, it's 50 millimeters long. It's just what I cut off the stock, so I'll need to take some off of that and shorten it up. When I do my cuts, I try to do it in such a way that I get the least amount of waste, but I always save my scrap because I inevitably end up using it for something, whether I'm using it for a template or maybe some part of my build calls for like a small piece. So I do save a lot of it. This shirt does not make good background, does it? It's like when you look at an old TV screen really close, if any of you guys are old enough to remember that. All right, so I got a kind of a nasty edge on here just from the sander. It's nice and smooth, but it has a little bit of flashing, so I'm just going to take a file and just kind of go across it. You don't want to do it too much because it'll make like a blade edge out of that, but just enough to get the sharpness off there, take off any little splinters because I don't want to find those in my finger later. And just smooth it up a bit. So let's start measuring here. So this is a 40 millimeter piece. Oh, actually it's incorrect, it's 39. Why did I measure 39? This one's 39 also, okay. So let's make our first measurement. And the measurements that I have on this piece of paper here are all based off of the outside dimensions, not the inside dimensions. So that first piece is going to be 7 millimeters long. Alright, so first bend is going to be made. I'm actually going to do this one by hand. Let's slide our trusty, come here, vise over here. Now, because these bends are these measurements are for the outside angle, I'm going to do my bend going away from the mark. And this is where you end up adding the length, because that curve from the bend ends up adding a little extra length to the piece. The first time when I made the buckets for the 933, I laid the piece out and then I did all my measurements on it, and then I bent it and ended up making it a little bit smaller than I had originally anticipated, which was actually a good thing because my buckets, I just did them off of eyeballing. I wasn't able to find any technical data for the actual dimensions of the bucket. So The only thing that I was able to find was the width of the bucket. Everything else I had to eyeball myself and then convert it to metric, which isn't very difficult at all. You just take the long, or I should say, convert it to millimeters. You just take the longhand version and then divide it by 50. So something is 4,000 millimeters for the 1:1 scale version. Then you just divide by 50 and you get the 1/50 scale version. Alright, so this first bend, where is my... So I'm just going to be comparing it to this little line right there to figure out what angle I need. Oop, wrong way, correct way. So I'm just taking this piece of paper, got the little mark right there, lining it up. Right. Alright, so set it on there and double check our angle, make sure it matches, which it does. I'll use the bending brick for this next one. Alright, got the bending brake mounted in the vise. Just one less thing that I have to hold on to. Now we're going to measure that next angle, 9 millimeters. We're going to measure it off this line right there, the back. Because I'm using the bending brake, I had to transfer that mark to the other side, but when I measured it out, so this top side is 9 millimeters, measured from the inside of this bend angle, it's 8 millimeters, so yeah, we're definitely, it looks like we're adding a millimeter to each bend here. I just don't want crooked bends. That looks good. Right. Okay. Close to almost there. Just need to bend that just a little bit more. Alright, time for that last bend. Now this one's going to be a full 90. Which I don't know if I'm going to actually be able to get out of this, because it might come up and hit the bending blade. Let's see here. Yeah, we're good. Okay. Alright, take it out, check it. We'll probably need to touch it up a bit here. Not bad. Okay, so I was kind of incorrect about how much extra material I would need for this. I erred on the side of caution and gave myself more material than I needed, but we have the hydraulic container here. We made the second cut here. Let's see, everything lines up relatively well, so the next thing I'm going to do is mark out the notch that I need to cut into this. Basically all this material right here is going to be gone, so that this can slide back and match up with this. Alright, so trying to figure out how to get this little notch area cut out. You can see all the red. It starts down here in the back and then it's all up here on the top. I need to cut that out to get this to fit around here. First I was going to use my saw to cut it, but it was kind of grabbing and I was having some issues with it. And so I figured right now would probably be a good time to, actually that's working great now that I'm doing the demo, but I figured it'd be a good time to try out the handpiece. But what I think I'm going to do is cut this first mark by hand and then come in with the tool and then cut the back out. Let's see if we can figure out how we're going to do that though. There goes the cutting wheel. Alright, got a new one on here. So it really doesn't take much to make these little wheels explode. So let's put it back in the most sturdy way that we've done it all day, because I don't think putting it in like this was very secure. And I think it allowed this to move around, which probably made that, that cutoff wheel explode as well. And you can't see it, but I am wearing safety goggles. And I'm glad I did, because again, this thing broke off into these little shards. So, round two. Let's see how long we can go without blowing up this one. That kind of worked out. All right. Change of plans. Nice. So managed to pull that off without mangling it too much. Let's put a different bit on here and see if we can square that up. Got another cutting bit on here. I don't know if you could see it, but it's kind of like a, looks like a spiral design. Just a lightweight cutting bit. And then I have another one here that I'm not going to use on this, but I was using earlier to cut through the zinc. And this is a bit more of a heavy duty one. I think this is for like cutting through grout. I'm not sure, but it's useful here. So what I'm going to do is I'm going to clean this up a bit, then I'll come in with the hand file and clean all the edges up even more. I'm just going to use this to kind of hog some of that material out of there. Again, I'm just kind of winging all this. It's the first time using this thing to do any sort of work on sheet brass. It's the first time using it really, period. So some of this is, or most of this is an experiment phase. I figure if I screw it up, I'll just go back and do it again. And sometimes you just kind of have to take a plunge and see if you're successful with something. And if you screw it up, you just do it over. It's not a big deal. That's how you learn. Wait. Looks good. All right, a little rough draft here of what we got going on. It is cut and everything is just kind of held in place by friction. I'll glue and solder stuff in place later, but this is pretty nice and snug just for starters. It will be soldered to this lower plate that I have on here once I get it squared up and everything. And then there is a bit of a gap right here, but remember, I still need to cap the ends of this off. I have to cap off both this piece right here, and then I got to cap this off as well. Alright, I finished the second one, and this one came out much cleaner than the first one. I also did it a little bit differently. Wait, this is the second one. So this is actually the first one that I bent, but the second one that I cut. The first one I did this little notch system in it, and I was going to slide it in under here. But then I noticed there was a bit of a gap in the back, so I compared it to the other one, and then I realized that I had made a little bit of a difference in the distance between here and here on this one. This one's a little bit longer, and it actually fits better. I also cut the back in this shape, so it butts up against that, and it just fits a lot flusher. And so when I look at this one in comparison to this one, I'm actually really displeased in how this one ended up coming out. You can see there's a bit of a void right there, and that's going to be a lot of work that I'm going to have to try to fill in, and it's such thin material that it's not going to be worth the work. So unfortunately this one is going to have to go bye-bye. I'll probably use the rest of the brass for something later, but I'm going to recut it because this one came out so much better. And what I did differently with this one in my cutting method is I used the handsaw to cut this first line right here, and then the rest of it I used the cutoff wheel, and I cut the back of that out, and it came out so much better. Trying to use the cutoff wheel to make this cut, I ended up bowing it a little bit. So I'm going to rebend another one to match the dimensions of this one, and it should give me a cleaner result. And the next thing I'm going to do is do the front and back panels for the hydraulic tank, and I wanted to add a little bit of a detail to it that I noticed on the full-size machine, and it's a bit of a studding that is on the face of the panel, so that you have the piece that covers here, and then it looks like it's riveted all the way around, and I want to kind of mimic that. So what I've done here is put a center punch into, sorry, I'm trying to adjust the light and talk at the same time. I put a center punch into my drill press, and I've rigged up my compound table. It's a Proxxon compound table. Let me come back a little bit, let you see that. And I've made an adapter plate to attach to the base of this. And it's nice because you can get a nice clean XY axis, so you can get straight lines. I'm sure I could probably hand tap this in, but it would not come out as good as if I use this. This allows me to go in 1/10 millimeter increments, which will allow me to get a nice even amount of these on here. Right about there. That line, that I don't know if you could see it drawn onto the brass from where you are, but that just indicates the outside of where the metal's going to get cut. So I want to step it in just a little bit. Alright. So I'm just using this as a press. I'm going to go every millimeter. Alright, we finished that up, and I'm really pleased with how that came out. It does give the illusion of it being riveted. As you can see, it did kind of warp it a little bit. It's part and parcel to the effect caused by putting a dimple in the metal, so I'll just take the little brass mallet and flatten that out. So as I previously stated, I wanted to redo this one. I just felt it came out kind of sloppy, and it was also just a little bit too short in this dimension, so I've rebent it, and it is a perfect match for this one. So now it's time to make that cutout again. The cut on the back didn't come out perfectly straight, but I'm not concerned with that because nobody's going to be able to see it once it gets put together. That's just simply going to be one of the anchoring points. I didn't cut all the way back on this line as well because I'm going to go back in and clean that up in a second with a different tool. I just wanted to make sure that I didn't cut too far and goof it up. So, alright, I'm going to come back with a file and square that up. Alright. So as you saw, I did cut the entire back of this off, which means I will now have to modify this and make a little cut on that part so that this can meet up with it. It would have been cool to be able to do it the way that I first wanted to, where this soldered to here, but it just left too much of a gap between this and the cab, and I didn't like the way it looked. So I had to go with plan B here. I'm just visually lining it up, making sure that this still lines up with that. Let's see if I can see in there at all. Yeah, it looks like it does. Yeah, yeah. Alright. So alright, so let's get that done. Ooh, that's right. This is the one that I had bent back, and because remember the first time I did it, I bent it this way, then it snapped. Sort of when I bent it back over, and I had intended to lay down solder in there to strengthen it back up, but apparently I didn't do that. Alright, well shoot. Aha, I got an idea. Alright, so this leftover, where are you? Flying off into the... So I'm going to repurpose this. I'm going to take and cut a piece of it and solder to the bottom and have it come up here so that I can still use this piece. I don't want to throw this away. That's a lot of brass right there. So I'll just remake this, but as an L-shaped bracket that will just sync up with this. Actually, I could probably just solder it to the top. Alright, let's get a little bit of soldering down here just so that I can get this little L-shaped piece that I cut off of the old tank that I'm not going to use. I'm just going to paint a little more flux on the back here. Get that seam on the side again. That other seam. Okay. This flux is a slightly higher temp flux, and it's a lot thicker than I need, so what I did is I just took a pair of pliers and just kind of crushed it and stretched it out, and then I'll heat up the metal and then apply the flux. I haven't soldered in a few months here, so might be a little bit rusty for the first one out. Let's go ahead and heat up the metal. So I forgot to turn my cell phone ringer off, and I received a phone call and it interrupted the video. So let's get back at it. I've used the torch on this for a little bit since we were last filming, and one thing that I always forget when I'm using the vise is the vise soaks up a lot of heat, which extracts it away from the brass very quickly. Being that this is thin brass, it doesn't hold the heat for very long, so using a high temp solder, I need to apply heat to it a lot longer. I had mentioned earlier using I don't even know what these are called, but it's one of these bad units, and it holds the brass in place. These are cool, but I do find that they do move just a little bit. So I'm going to take it out of the vise now that it's cooled down, and I'm going to rig it up in the little tree stand and see if we can get this solder to settle down a little bit flatter. If not, it's not a big deal. It's pretty secure right now. As you can see, the solder did creep down the sides a little bit, but I would like to see a little bit of a better spread of the solder. And then we'll take and grind the excess off of there. Alright, much better. The vise is useful when I'm creating parts like buckets where I have multiple seams going on at the same time and I don't want other ones to release. That's very useful for like holding it by the side. But when it comes to simpler solders like this is definitely a better method to use. But I did like how starting it in the vise did allow me to get a real good grip on this and then go from there. So pull it out and then I'm going to take it and rinse it off. Alright, looks good. I hit it with a file on the back there, and then we're just going to take the wire wheel and clean up some of the discoloration and burnt flux here. Cool. That's a good bond. Let's see if it fits back in here. Yippee yay! And our new piece. Alright, this is the new one. And as you can see, that fits in pretty cleanly. I like it. I'm glad I redid this piece. Much more satisfying result. I think I might have gotten lucky with this one. As you can see, the alligator clips are just big enough to hold all this in place, this little box rig got. So I think we might be in good shape here. I've cut smaller pieces of solder. I think I used too much on the last one, so I've cut it down just a little bit more, roughed up all the connecting points with sandpaper, and then applied flux with a brush. And now we're going to apply heat to the outside and see if we can get all this to join up. Lower my heat just a bit. Again, it's best if when you're torching to not apply the flame directly to the flux or the solder. Alright, let that sit for a second, cool down. I think we're good. So we'll come back. I'm going to go, actually I think I'm going to, I want to rinse the burnt flux off of there first because it is an acid and I don't want to get that on my fingers. And then I'm going to grind the edges off, see how our final product looks. Or not final product, but the final product of this soldering job. Alright, panel 1 is complete. I got all the excess off of here. So my order of operation for getting the excess material off of here, and I can actually see a little bit that I need to clean up right there. I use my belt sander first to get hog most of the bulk off, and then one of my grinding bits on here to get even closer. And then when there was about just a little bit of material left, I used this to bring it down even closer, and then using a sanding stick to blend the rest of it in. I'm going to clean this up a little bit more because I can see where it's sticking out just a bit right there. And then I'm going to create actually we'll do the other one, the outside panel on my second tank, and then we'll sort out this inside panel. I'm not going to cover it completely because a lot of it's going to be hidden, so it'll probably just be like a small piece like this just to close the visual gap that's there. And for this one I used my high temp solder, and then when I go to attach this to the base plate we'll use the low temp solder. Alright, so we have a lot going on with this setup right here, and I will explain all of it. So earlier I mentioned that controlling the heat when you're doing multiple joints of soldering is really important. So that's what we've got the vise here doing. You can see that it's connected to the part that I already soldered earlier, and basically the vise is going to draw the heat away from those joints because the heat transfer is going to try to heat all of this material as well, and it's going to soak it all up. This right here is the main arm holding my piece, and then this one under the bottom is just to offer some support, because these don't really lock in place very well. These whole arm setups, they really do leave a lot to be desired. So I already have the flux in there, and then I took a little piece of solder and put it inside on top of the joint. And if the solder looks weird, it's because I'm using this really thick gauge solder. It's much bigger than I need, and because I don't have another coil of it, I've only got a coil of my lightweight solder. I have to take this one and smash it down with a pair of pliers, make it flat, and then cut it into little pieces to put in there. Eventually I'll get another coil of that same hardness of solder, but for right now I've just got that one and then this really small lightweight one, which we'll use later. Nice. It's a lot of solder. It's much more than I needed, but it doesn't matter because this part's not going to be seen. It's all on the inside. When it gets that nice glassy finish to it, you know you've got a good joint. If it spread out a little bit more, that would be even more ideal, but again, because of the vise, we are getting a lot of heat being dissipated on this end, so this whole area right there is going to be substantially cooler than the area that's just had the heat applied to it, and it's going to take a lot to get this area the same temperature as that, because I have to get all the surrounding metal up to that temperature as well. But for what we needed it to do, it looks like it worked really well. Remember, these things are hot, so don't try to just take them off by hand. And yes, I did do that on accident, and I think I did it more than once, because I am that dumb once in a while. Oh, another thing that I didn't point out, and it was kind of hard to see because of how this was turned, but you can see I had another clip down here on the bottom holding this together just in case this wasn't enough to keep those joints from slipping. So now I'm going to take and grind all that excess off, and this will secure the rest of this closed, so when it's installed, don't get any light leak or anything in there. Alright, since we last filmed, I got a few more things done on the model, and I will show you guys what we're doing. So first of all, I've finished soldering all of the, in the camera, all of the joints on these, on the tanks, and I've buffed it all out, cleaned it up, made all the joints look good, and then I've created these little brackets right here, which are what Kat uses to hold the tank down. I imagine it's secured on the other side as well, and then I've laid it all up on the now paint-free model base. I just used a spray-on stripper, took all the paint off of it, and then I've jigged it up here on my vise. This is something I don't typically do. I don't like to place it on my model and then solder it that way, but I was messing with this for probably a good half hour trying to figure out how to rig all of my brass up in such a way that I can put it together so that it goes on the model the way I want it to, and I wasn't able to get it done. So I've just rigged it up on here, which seems to be the most stable way that I can do it. I've put down my flux, and then I've put my really lightweight solder on there. So what I'm going to do is just apply heat to it and then get the lightweight solder to hopefully bond everything together without the stuff moving. I've occasionally had stuff move around while I've applied flame to it. I don't know why. I think it's just because of the heat changing the metal and it just wants to move. So this isn't something that I've done before, so we're about to find out if this works or not, or if I'm going to have to take it all apart and redo it. So let's give it a go. And I'm going to be applying the heat from the bottom, or attempting to apply it from the bottom. Let's see what we can do. And all I'm doing right now is I'm just watching the solder, seeing where it flows and where it doesn't, and then applying heat to the parts that aren't flowing down. It looks like everything on that side is satisfactory, so I'm just going to apply a little bit more heat over here to get that solder to settle a bit more and coming from the inside. Because again, I don't want to heat up the other welds too much and make those break. So let's just let that cool. It looks good, but I found with soldering sometimes looks can be deceiving. So let it cool down a second and we will test it and then apply more solder where needed. I think I will end up needing to apply more to this guy, we'll see. And then once all the soldering is done, I'm going to drill a hole there and drill a hole there, and then we're going to put a little bit of a little collar of brass tubing in each spot to make it look like the gasket that is on the dozer, that helps kind of probably keep this from vibrating when the dozer's running. Alright, let's give it a little test here. Yeah, that's going to need to be soldered again. Okay. I was afraid that was going to happen right there. I didn't put a lot of solder down on that spot. That guy's good though. Alright, so I will cut another little piece of solder and apply it right back in there. Somebody forgot to turn their cell phone off again. Alright, let's let that cool and see if that adhered it the way I wanted it to. Then once all this is in place, I'll probably come back and clean it up. These little metal brackets that I made, I just took larger bits of scrap. I've pretty much used up all the scrap, by the way, that we had left over from all of our cutting and all the other little things that we've done. It's all gone to good use on these, but I took and just cut out a little piece of it and then used these little bending pliers to make that little U shape, and then took it to the belt sander and then cut it into that triangle shape. I'm pretty stoked on that. This needs to be squared up a bit. I need to go clean this up a little bit. These aren't exactly matching, so I'll take a lightweight file and fix that up. And as you can see, that doesn't sit down on the inside, but I needed it to clear that, and I didn't feel like cutting a notch into it. I don't care if it's completely soldered down, but got a solid grip on there. It's good. I'm also going to take a little dental tool and go around all these seams right here, like just basically it's like a bent needle, and just kind of clean it up so that it doesn't look like solder. But I'm happy with it. And then eventually we'll punch a hole in it, add the filler cap, and then add the hydraulic pump at the top. Well, that concludes the episode. I hope you guys enjoyed it. Again, thanks for your continued patience with my novice filming skills. Hopefully they will get better. I think they'll get better. They should definitely get better. Next week, we're going to finish this bad unit off. We're going to finish off the details for the tank. We're going to finish off the rear panel and probably all the other little details aside from the driver's compartment that are involved with these two modules. And by two, I mean this one and the one for the other D11 that we're building. You guys have a good week. I'll see you next time.